Thank you, everyone, for coming. My name is Anthony Lineberry. This is David Richardson and Tim Wyatt. We're researchers at Lookout. We do a lot of cool stuff with mobile security. So today we're going to be discussing permissions on Android and some of the fun things that we can do with and without some of those permissions. So to get started, things we're going to cover. We're going to do a brief overview on the Android internals, just to get those of you who don't have any context about the important components within Android and a lot of the things that we're going to be discussing, as well as the security and permission model, basically just how their sandbox works, their permissioning, how that's implemented. But then we're going to discuss some of the fun things that we can do with the permissions. Basically things that we can do without permissions, things that we can do with permissions to do things that that permission didn't intend for us to do. Also, we're going to discuss system logging and how we can leverage that to perform a lot of these actions as well. After that, we'll discuss routing and a lot of the problems surrounding that and everyone's quest for root on these phones. And then we'll discuss some mitigation, basically things that we would like to see people do, the end user, see developers do, manufacturers and OEMs. So let's get started. The Android internals. So the first thing we have is our Android manifest. It's something that every application has. This is a large XML file. It's stored as binary XML because things need to be small on mobile. The manifest contains everything important about the application. Primarily, it's going to contain the package name, which is a unique identifier for every application. Essentially, this is when you see like com.android.sms or something like that. Those are the package names. These also are going to describe all of the components of the application. So all of your activities, all of your intents, broadcast receivers, that kind of stuff. Also, all the permissions that the application needs. So it's going to declare both requested permissions that the application needs to access a lot of the protected APIs and a lot of the content, as well as declare permissions for that other applications would need to access components within the application itself if they want access to some of the activities or to be able to receive intents and the application has set permissions to access that. Activities. Activities on Android are basically just a UI screen. This is a way for a user to interact with an application. The activity itself is going to be composed of views, which on Android are essentially just your UI widgets, your buttons, image views, text views, a lot of things like that. The activities themselves are managed in an activity stack. So essentially, any new activity that is created or started will be running in the foreground on top of the stack. This will be in an active state. Any older activities or before that are going to be lower down on the stack. Any activity further down on the stack will also be in a pause state where it just maintains state of the activity itself. The activities will stay in this activity stack until the activity itself finishes, or in scenarios where the system memory is low, if an activity is paused, then it can be killed by the system itself. Activities can be started by other applications. So an application itself can start a remote activity in another application. So a scenario for this where someone might realistically do this, a lot of applications will request a location permission. That location, if they want access to fine-grained location data as far as latitude and longitude, they have to have their GPS enabled. So an application can start an activity to fire up the settings for the location that are actually built into Android, pull that activity up, and then the user can check the box to enable GPS. Once the application sees that that setting is enabled, then they can finish that activity and be brought back to the original activity that they were at. The activities themselves, when you start these activities within another application, run within their own application's process. So if you're starting some other application's activity, you won't necessarily have access to any of that application's data or any of the activities data. But starting activities within your own application, of course, you'll still have access to a lot of the data associated with that. Activities, like we said earlier, you can define in the manifest. If you don't want people to be able to start your activity, you can request a permission to be able to enforce access to this, that any application that wants to start your activity would need to request this permission and be granted that to start it. Intents. So Android intents are basically, in the documentation it says an abstract description of an operation to be performed. So this is essentially just a simple data structure of an action and data associated with that that's passed in the form of URI. And we use this as basically a low overhead IPC between applications so that we can say, hey, we want to start a browser, here's a URI for this, or we want an action view, here's some content data. We can use the intents to start, or as we said, okay, so we use these to start an activity. We can also use these to broadcast system-wide an intent with send broadcast. So in an event where we receive an SMS, or an SMS is received on the platform, an intent will be broadcast out to everyone, to pretty much anyone who sets up a listener can receive that intent if they're interested. We can also use these to communicate with the background service. So if we have a service set up in the background, then we can send intents to that along with data to notify it about certain events, and that kind of stuff. Broadcast receivers. So this is the receiving end of an intent. When you send these out, an application will have a broadcast receiver set up with some kind of intent filter of the intents that they want to receive. So if you want to be notified about an SMS being received, you'll receive an intent usually containing the SMS PDUs, I believe. So we can create these in two different ways. We can either create a broadcast receiver dynamically in our code with register broadcast, or statically within the manifest using the receiver tag, and we can define that. And we can receive two types of broadcasts, two types of broadcasts with our receiver. So we have a regular broadcast, which is just sent out asynchronously en masse to every receiver on the system. These types of broadcasts cannot be aborted, and you can't do anything with the result. We also have an ordered broadcast. This is a broadcast that's sent out sequentially to all the receivers. So as it goes down the line, a receiver they'll receive the result from the previous receiver and do any kind of processing they want on that. They have the option to abort that broadcast, and from that point it won't go any further down the line to any of the other receivers. And also we can pass our own result to the next receiver down the line. Much like the intents and activities, we can enforce permissions from both sides of either the sender saying, this is the permission that you need to have if you want to receive this broadcast, or if the receiver is going to receive it. The receiver can also say, this is a permission you need to have if you want to send me an intent. Services are basically what they sound like. It's a component that we'll use in the background to do processing. These are not a separate thread or a separate process. The services themselves run within the main thread of the application. So if you want to do any kind of CPU intensive processing or anything that's going to do some blocking, you're going to want to spin off your own threads to do that kind of stuff. But essentially, we can use these much like an activity. And we can also enforce permissions like the activities and intents before, where you define a permission to say if you want to access this service and use it, you need to have this permission. So let's talk about the security and permission model of Android. So everyone knows that Android is using a sandbox. That's one of the highlights that everyone likes to talk about. The sandbox itself is not a VM. A lot of people assume that the sandbox is basically the Dalvik VM that's running, but the sandbox is actually just users on a Unix system with UIDs and GIDs. So essentially, every application that you install in the system is going to run as a different user. So applications, in that sense, won't have permissions to access other applications, files, and data on the file system. And every process is running as a separate UID. So all those processes are going to have a VM, which is a lightweight. So the Dalvik VM is just a lightweight Java-like VM that's actually based off of passing registers rather than on the stack. If you find a way to break out of this VM through an attack, it's not going to gain you anything because you're still just running within that process with those users' permissions. And there's a lot of legitimate ways to break out of the VM anyway using JNI code, which is natively supported now. You can have a shared UID between applications if they request to do this in their manifest. Both applications would have to request this, and essentially these two separate applications would be the same user, but both of these applications need to be signed with the same signer key. The permissions on Android essentially just act as fine-grained access on top of the sandbox to be able to access protected APIs content. So if you want to be able to access the SMSs that the user is receiving, if you want to be able to access their contents, if you want to be able to access the internet and have network communication, you're going to need to request a permission. And as I said, these are all declared within the Android manifest. So with all of that background in mind, David is going to talk about some of the fun things that we can do with these permissions.
Thank you, Anthony. So yeah, now we move on to Android development. And my motto here is, why ask for permission when you can ask for forgiveness? So why are permissions important? Permissions, they gate what an app can do, and these are actually user visible. So I pull out my phone, I access the Android market, I click on an app that I want to download, and I see a screen like this. So this is Pandora, and I see that it can access the internet, it can read my phone state, and do other various things. Now, as a user, I'm required to okay this before I can download or install an application. There's no you can't agree to allow an app to do some things but not others. It's all or nothing. If you don't want to allow these permissions, you click cancel, you can't install the application. And so users can look at this screen and they can decipher to some degree whether or not this makes sense for the application. So it's Pandora Radio. Obviously, it needs to be able to access the internet. It wants to be able to read my phone state because it doesn't want to keep playing music if I receive a phone call, for example. So let's look at another example. Here are two different tic-tac-toe apps.